Sahu from Department of Mathematics, the University of Bardwan. Today I will discuss about on extending binary and ternary Goldbach's conjecture, the decomposition of even and odd integers as a sum of prime numbers. So these are the contents which I am going to discuss during this short lecture. So which is divided into introduction part, essential preliminaries, research gaps, motivation, etc. And then conclusion, future works, etc. This is the abstract which I have already sent. So coming up to the brief outline, that is the objective of conjectures topic and proposing hypothesis and the future scope of our conjectures topic, and this is how we will complete our today's discussion. So coming up to the introductory part, in 1742, Christian Goldbach proposed a conjecture in a letter to Leonard Euler known as Goldbach conjecture. Seemingly simple, the conjecture was wrestled with this conundrum for the centuries, and mathematicians are eager to prove such kind of conjecture. We have extended this conjecture for specific kind of even and odd integers. So basically it is divided into two different parts. That is the binary Goldbach conjecture and the ternary Goldbach conjecture. So coming up to the essential preliminaries part. So the positive integers are divisible by a unit, which is very simple part, that unit of positive integers, and itself only known as the prime numbers, which is very simple. And 3, 5, 7, 11, 13, etc. are the prime numbers, we know that. And what about the twin prime numbers? A twin prime is a pair of prime numbers. The difference which is 2, like 3, 5, 5, 7, 11, 13, 79, and so on. So coming on to the shape primes, it is the most important part because we have utilized such kind of primes into the even and odd decomposition. The prime numbers of the format 2p plus 1 is called the shape primes, whereas the corresponding prime number to 2p plus 1 is known as the Sophie-Germain prime. This is the 5, 7, 11, 13, and discussed as follows. This is the numbers. 2 into 2 plus 1, etc. Fundamental theorem of arithmetic says that any positive integer is either 1 or a prime, or it can be expressible as a product of primes. The representation being unique except for the order of the factors, which is very layman and known to us. So coming up to the binary and Goldbach conjecture and ternary Goldbach conjecture, any even integer greater or equals to 4 can be expressible as a sum of 2 primes. And ternary Goldbach conjecture says that any odd integer greater than 5 can be expressible as a sum of 3 prime numbers. Whereas the ternary Goldbach conjecture is already proved, but till now we have no any analytical proof for binary Goldbach conjecture. But in this discussion, we are going to extend such kind of conjecture. So what about the research gap? To justify the novelty of our research work, we have clear some research gaps as follows. Till now, the truthfulness of Goldbach conjecture is important, and it has been checked for millions and millions of even integers, and it is verified for very large even integers, and it holds that true. But strengthened version of Goldbach conjecture is not considered till now, and this is the novelty of our research work, that we have considered the extended version of Goldbach conjecture with the specific type of even and odd integers. So there are no advancement beyond the simple requirements of the Goldbach conjecture. So coming up to the research motivation, as the fundamental theorem of arithmetic implies the primes are building blocks for the integers, non-primes. It relates the integers to the product of primes, whereas we are relating the summation of the primes with the even and odd integers. The prime numbers of the format, the positive integers, if we consider, then the number of positive divisors can be given as follows, which is denoted by the tau of I, and the number of the divisors connected to the aspect of products of primes. We have extended the relation and inferred few hypotheses. So these are the objective of our current research topic, that is extending binary Goldbach conjecture, extending the ternary Goldbach conjecture, and investigating the generalization of Goldbach conjecture for the specific format of even or odd integers with the number of positive divisors. So coming to the methodology of this research topic, that is to verify the truthfulness, we have conducted computational verification. These hypotheses are computationally verified up to large even integers, and our exploration implies a potential framework for the future exploration in the number theoretic aspects and the prime number distribution system. So coming on to the hypothesis which we have inferred here, the members of the set 3k plus 1 greater than 10 with exactly 3 positive divisors can be expressed as a sum of 3 twin prime numbers. This is our first hypothesis. Our second hypothesis says that the members of the set 4k plus 2 greater than 10 with exactly 4 divisors can be written as the sum of primes, among 3 of them being shape primes. Which I have already stated that shape prime means the 2p plus 1 format primes, but p is called the Sophie-Germain prime, and also the 3 twin primes. So coming on to the third hypothesis which we have, the members of the set 6k plus 4, where a is greater than 10, this kind of numbers are greater than 60, So greater than 10 with exactly 3 positive divisors we have can express it as a sum of 3 twin prime numbers. The members of the set 8k plus 6, these are fourth hypothesis with exactly 8 divisors can be written as a sum of 2 prime numbers with at least one of the prime. Expressible as the format 4p plus 3. This is also the extension of the SOP German prime. So coming to the verification list we have for the 4 hypotheses we have already stated in the previous slides. That is the category 1 table, this category 2 table. So these are the verifications. We can also verify this result as which is given as follows. And this is for the category 3, which is also for the category 3 results. This is for the category 4 we have. And these are the verification list. We have a million checks up to the computational verification upon it. And we have only stated few of them. So these are the conclusion of our research work that applying all of them, we can claim the generalized version of Goldbach conjecture. The methodology outlined in the work not only advances Goldbach conjecture for the specific and odd even inches, but also provides a potential pathway for resolving patterns of the twin primes and step primes into the odd and even integers. So what about the futures of our conjectures topic? The proving Goldbach conjecture analytically by strengthening its condition, which is very important. That is this is the motivation we have already stated that, and extending the Goldbach conjecture for the integers of the format nk plus n minus 2, where k is a natural number. If we plug into it n equals to 2, we have the strong Goldbach conjecture, which is a binary Goldbach conjecture. Investigating the connection between even and Sophie German primes and investigating the connection between twin prime and Sophie German prime in the later and future works. So these are the real life aspect of our research topic, that prime numbers are fundamentally intuition decreasing system like RS intuition distribution process, which is secures online communications, and extending Goldbach conjecture, which is already a hypothesis driven approach we have stated here, has driven the development of efficient algorithm for prime checking and factorization. And they have the real life applications too, like big data processing, integer factorization problems, efficient resources allocation, etc. So these are my useful references which I have used during this research work, and these are my acknowledgement part. I want to express my humble gratitude to Dr. Sudipto Sinha for his invaluable presence during this whole research work. Without his cooperation, it couldn't be accomplished at all. And thank you for your patience.
Thank you, Rudranil, for a nice presentation.